This is May 2015, standard level paper 1, time zone 1, question 10, the end of section B. So you should expect this to be on the tougher parts of the paper. And you can see from looking at it straight away, it's going to involve some probability. But actually, it ends up tying together two areas of the course. Probability being one of them, and we'll get to what the other one is as we go through the question. Anne and Bob play a game. Anne's dice has 3 green faces, 5 red faces. Bob's dice has 4 of each. They take turns rolling their dice, and the first player to roll green wins and gets to go first. So, what's the probability that Anne wins on her first roll? That's a trivial question almost at this stage. And it says find, but this could easily have said write down, because all you have to do is take this information here, and has 3 green faces, 5 red faces. Probability that Anne wins is the probability that she gets a green face, which is 3 out of 8. So that's that done. Part B, part 1. Probability that Anne wins on her third roll is 5/8 times 4/8 times P times Q. Let's break that down. 5/8, 4/8, P, Q, 3/8. Okay, the 5/8, well, where does that come from? That 5/8 comes from Anne losing on the first roll. On her first roll. The 4/8, well, that comes from Bob losing. On his first roll. P and Q happen, so what must P represent? Well, Anne lost on her first roll, Bob lost on his first roll. P must be Anne loses on her second roll. Anne loses on her second roll. Q must be, by the same logic, Bob loses on his second roll. And then the third one, the 3/8 here, is Anne winning. Anne wins on her third roll. So what are these missing probabilities? What's the probability that Anne loses on her second roll? Well, it's the same as the probability that she would have lost on her first roll, or that she would have lost on her fifth roll. It's 5 out of 8. And what's the probability that Bob loses on his second roll? Well, his is 50-50 every time, because he's got 4 of each. So that's 5/8 and 4/8. So the first one is P, and the second one is Q. Okay, let's try and squeeze big part 2 in as well, because that relies heavily on our answer to be part 1. We've got the probability that Anne wins on her 10th roll is given here, 3/8 of R to K, where R is in Q and K is in Z. Let's just talk about what those mean a second. R in Q means R is a fraction, a rational number, and the Q stands for quotient. So it's a real number that can be written as one thing over another. 3/7, 10/100, 20/64, whatever it is. And then K is in Z, means it's an integer, a whole number. Often you probably won't have to worry too much about when they say things like this, because you can just work it through, and if you're doing everything right, your answer will come out. R is with R being a rational number and K being a whole number. But it's a little clue as to what you should be doing. Right, the probability that Anne wins on a 10th roll is 3/8 of r to the k in the yellow there. Let's have a look at what happens each time they roll. If Anna's going to win on her 10th roll. If Anna's going to win on a 10th roll, that means every roll that comes before, Anna and Bob must be losing. So just like here, where they both lost, was 5/8 and 4/8, 20/64. The next part, PQ, where they both lose, was 5/8 and 4/8, 20/64. Every time that Anna loses and Bob loses, the probability is the same, 5/8 times 4/8, 20/64. So, that must mean that to get to the 10th roll, it'd be 20/64, they both lose the first time, 20/64, they both lose the second time, 20/64, and so on, until the 9th time, 20/64, and then the 10th time, Anna wins 3/8. And that looks awfully similar to what was going on in this yellow blob over here, where you've got r to the k. Well, what's r then? R must be this number that's being multiplied by itself k times. (20/64, 20/64), and so we've basically written down what the answers are. R is equal to the number that's being multiplied over multiple times, 20/64, and k is equal to how many times it's being done. We already said that's 9 times, because the 10th time is when she wins. Now this should all sound very familiar. Let's see if we can get this back. Get this back in the right place. This should all sound very familiar when we're multiplying things together. And like I said, the top of the question, this is tying together probability with a different area of mathematics, which is geometric series. In fact, this situation is called, although we don't study it formally, this situation is called a geometric series, in the same geometric progression. And a geometric distribution. In the same way that we study the normal distribution and the binomial distribution, there is also a geometric distribution. And although it's not explicitly on the syllabus, because all the information that you need is on the syllabus, they can write a structured question like this, and at the end expect you to synthesize these two areas of knowledge, the probability and the geometric sequences, and put them together to get something unfamiliar. And that comes to the forefront in part C. If you don't spot that, we're dealing with a geometric series. Finding the probability that Anne wins the game is tougher. But spot that, then you can just use your knowledge about geometric series and say, well, what's going on here? Well, we've just worked out there's another clue here in the R. Just stop doing that. R, you're familiar with using R as the ratio. We just worked out it's 20/64. I suppose you could cancel that down, 10/32. 5/16. Let's use 5/16. And what's U1? Well, it's easy to work out what U1 is, especially given way back in part A. Way back in part A, we worked out what U1 is, the probability that Anne wins on her first roll. So it's all linked together. you'd have it written down in front of you. I'd have to click back a couple of slides, but I can work it out again. 3 green faces, 5 red faces, u1 is 3/8. And we've seen that occurring, it occurs there and it occurs there. So this is just a case of saying, well, what's the probability Anne wins? It's just the sum of her winning on the first roll, her winning on the second roll, her winning on the third roll. And because it could in theory go on forever and ever and ever, it's the sum of an infinite geometric series, which the formula booklet calls S, as you know, is equal to u1 over 1 minus r. It's a non-calculated paper, so you have got to evaluate this. You've got to do this calculation by hand. Hopefully it's not too difficult. That's why I suppose doing this cancellation is probably a good idea. So that's all we're doing. u1 is 3/8. 1 over 1 minus 5/16. 3/8 over 1 minus 16 minus 5 is what? 11/16. Now, when you've got fractions within fractions, there's lots of ways to deal with it. I like to think of dealing with it like this. The most familiar thing we can do with fractions probably is multiply them up and cancel them down. You've been doing that since probably about 8 years old. So I can multiply the top and the bottom of this big fraction by any number I like. I'm going to choose the number 16 because that's going to cancel the 16 here, and it's going to cancel the 8 there. So 3/8 of 16 is 6 on the top, and 11/16 of 16 is 11 on the bottom. So the probability that Anne wins is 6 out of 11. I want to say one more thing about why we can take this approach. The sum of an infinite geometric series only makes sense providing the following condition is true. R has to be between 1 and -1. And if we look at the value of R, 5/16, then that is the case. So this approach is valid because R is less than 1. And in fact, R has to be less than 1 in a geometric distribution because it's a probability. And probabilities are between 0 and 1.